Hello, and welcome to Traditional Loops and List Comprehension. My name is Laura Harris, and today we'll be discussing the similarities and differences between these two things as they relate to Python programming. Let's get started. So here is a brief lecture outline so you know what we will be covering today. I'll give a brief introduction, and then we will achieve two learning objectives. First, we will apply traditional loops and list comprehensions to solve basic programming tasks. Then we will analyze the pros and cons of using traditional loops and list comprehensions. And then we'll end with a conclusion. I do not assume you know anything about Python programming, so I'm going to start with a couple of basic definitions. What is a collection? Well, a collection is a built-in variable in Python that stores multiple values. For example, strings store characters, tuples and lists can store booleans, which are true-false statements. They can store numbers, such as floats or integers, or they can also store characters like strings. So what is a list? A list is a collection that is ordered, changeable, and allows for duplicate members. So here is an example of a list. Let's say you are tasked with generating a list of perfect square numbers smaller than 100. You can define a list of these numbers. So for example, we take the variable squares and we set it equal to a list that is defined within square brackets. As you can see, if you run this code, you can print the type of the variable squares and see that it is indeed a list. And if you print the variable squares itself, you get the list that you typed in to begin with. Remember that lists have a defined order. Items can be added, removed, or changed, but the order will not change unless you give Python a function to do so. Lists can contain any type of data, and it can also contain different data types within the same list. So what is a traditional loop? Well, a traditional loop is a method to iterate over items in a collection using for or while loops. So going back to our original task, using a for loop, I can define squares as an empty list and then say for the variable x in range 10. So since 10 times 10 would be 100, and I want values less than 100, Python always uses one less than the number, excuse me, that you are putting into the brackets. So this would be for x up to 9. If I take numbers 1 through 9 and I square them, I then get a list exactly like the one I had on the prior slide. Alternatively, I can use the while loop. But in order to use the while loop for this kind of task, I would have to first define the variable x as a counter. And then I would say while x is less than 10, square x, and put it into the squares list. Notice, though, you're going to need to iterate your counter. Otherwise, you're going to create an infinite while loop. That's not good. Over here, I've timed running both of these codes, and you'll notice that the for loop is slightly faster. You'll also notice that the for loop has fewer lines of code than the while loop does. So for the purposes of the rest of this presentation, we will focus on the for loop as the traditional loop under discussion. Let's do a couple more small programming tasks using the for loop. So task number 2, generate a list of even numbers less than 20. The idea applies where you're going to iterate x all the way up to 19, 20 minus 1. And every number between 1 and 19, you're going to divide by 2. If you divide the number by 2 and you get a 0 as a response, you know the number is even, and that number can be added to the evens list. You'll see the result printed here. Similarly, for task 3, we're going to generate a list of possible number pairs using the numbers 0, 1, and 2. This would be handy, for example, if you were doing Cartesian coordinates or matrices, for example. Here you have a for loop that is nested within a for loop. So for x in range 0, 1, 2, and then y in the same range, you get the pairs that you see here. So what is list comprehension? Well, list comprehension is a concise way to create lists using Python syntax. Here is how you would do all 3 tasks using list comprehension. You'll notice that all of them incorporate the for loop within the line of code that is defining the list within the square brackets. In the case of the generating even numbers, or in generating possible number pairs, we combine the for loop with a conditional statement. So then that way we can select certain numbers, or even a for loop within a for loop, in order to generate the pairs. But regardless, you always get the one line of text, which is way shorter than using the traditional loop. So now that we have discussed, or I should say applied, 3 tasks using both for loops and list comprehension, let's analyze the pros and cons of traditional loops versus list comprehensions. There's 3 criteria I'd like to discuss here. The first is performance, or speed, of the algorithm. List comprehensions are often faster than loops. And this is because they use optimized C code under the hood of Python in order to execute the list comprehension. Traditional loops, on the other hand, are interpreted by Python. And Python is inherently a slower programming language than C is. Further, there's shorter syntax. As we just saw, list comprehension is more concise, often can be coded in one single statement, and that leads to more effective code. With that said, we also have to consider readability. Traditional loops are easier for humans to read, particularly when they're incorporating complex logic, such as a for loop within a for loop, or within a for loop and another for loop. You see where this is going. So here, we have to keep these in mind when we're analyzing which ones to use and when we should use them. So let's give an example. Here, I have taken the function for one of the for loops. This happens to be task 1. And then I took the list comprehension for that same task and defined it as another function. And then I'm going to run each of those functions 5 times in order to generate data that I can analyze. I'm going to monitor the time it takes to run it and then print that time accordingly. I'd like you to notice, though, that I'm using a big data set. So before, when we were sending numbers less than 100, now we're doing numbers in the millions. And the reason I've increased the data set size is because you cannot effectively see that list comprehension is faster on the smaller data sets. Remember, I said that they weren't always faster, and in the initial examples where you're only dealing with a short list, the timing is relatively the same. However, when we run this algorithm, you can see that first off, it takes fewer lines of code in order to run list comprehension. And for every task we discussed earlier, the list comprehension is substantially faster than you see with the for loop. So this demonstrates what we were just discussing on the previous slide. And if you would like to take a look at this yourself, check out my GitHub. It's in the Jupyter Notebook section. So in summary, we use list comprehensions for simple and concise operations. We use traditional loops for more complex logic that's going to require human readability. And at the end of the day, it's best to choose the method that improves the code clarity and performance per your specific task. And I cannot emphasize enough per your specific task. When I personally am programming, my beta program will be done with for loops, because I myself am still working through the logic. I may need to show that logic to somebody else to get their feedback. When the code runs, albeit slowly, and I want to speed it up, think programming optimization. That's when I go through, find my for loops and rewrite them in terms of list comprehension statements. So just to make sure we accomplished what we set out to do today, excuse me, I did a brief introduction. Hopefully you will agree that we applied traditional loops and list comprehensions to solve basic Python programming tasks. I hope you'll also agree that we analyzed the pros and cons of using traditional loops compared to the list comprehensions. We did a brief conclusion. And so with that said, I'd like to thank you today for watching this video. Feel free to like or subscribe or leave a comments down below. And I look forward to seeing you in the near future with your Python programming needs. Have a great day.